Dear students, today I will be discuss with you some important MCQ from the chapter Chemical Kinetics. Question number 1. For a gaseous phase reaction 2A plus B2 giving the product 2AB, the following rate data was obtained at 300 Kelvin. So this is the column. Rate of disappearance of B2 moles per liter. This is given, and these are the concentration of A and B2. Okay, so see from this the rate constant for the reaction is what? Okay, the rate constant K is asked. So we'll do question number 1. See, rate minus half dA by dt is equal to minus d by dt B2 is equal to plus half dAB by dt. Okay, so rate is equal to, so you give provided rate is equal to minus d B2 by dt is given for this 1.8 multiplied 10 to the power minus 3 is equal to K A the power x B the power y. Okay, so similarly, so you take 1.8, so you can take the concentration 1.8 multiplied 10 to the minus 3 is equal to K A concentration 0.015 x 0.15 y. Okay, is next 1.08, second one 1.08 10 to the minus 2 K 0.09 x 0.15 y. Okay, next 5.4 10 to the power minus 3 K 0.015 x 0.45 y. Okay, so these things are given. So this is equation 1, equation 2, 3. Okay, so equation 1 divided equation 2, you will get 1.8 10 to the minus 3 divided 1.08 10 to the power minus 2 is equal to K 0.015 x 0.15 y divided K 0.09 x 0.15 y. Okay, so by solving you will get this side 0.16 and this side K cancel, this side you will get 0.16. This is x because these two cancel. Okay, so therefore x is equal to 1. Then equation 1 divide equation 1 by equation 3, you will get 1.8 10 to the power minus 3 5.4 10 to the power minus 3, k 0.015, x 0.15, y divided k 0.015, x 0.45, y. So here you will get, by solving, here you will get y is equal to also 1. Okay, so therefore 1.8, put this x and y value, will get 1.8 multiplied 10 to the power minus 3, k 0.0151, 0.15, y. Okay, so k you will get here, k is equal to 0.8 moles inverse liter inverse, moles per liter meter in minute inverse. So your choice B is the correct answer. Okay students, next, inversion of sugar. Inversion of sugar follows first order rate equation, which can be followed by noting the change in rotation of the plane of polarization of light in the polarimeter if R infinity, RT and R0 are the rotations at T infinity, time T and time 0, then first order reaction can be written as what? It's question number 2. Okay, so your sugar C12H22O11, okay, plus hydrolysis water giving C6H12O6, C6H12O6. One is glucose, other is fructose. Okay, so here K is equal to 2.303 by T log R0 minus R infinity by RT minus R infinity. Okay, so choice B is the correct answer. Okay, next, which of the following is correct? See, these are the given, which is correct. Catalyst decreases the activation energy. Okay, catalyst decreases the activation energy. Okay, so it is not correct. What it will be? What is its correct form? You see, A is given. What is A? A is given log K2 by K1 is equal to EA by 2.303 by, it should be R. Okay, for zero order reaction, T half is directly for the initial concentration. Okay, so these are wrong. Only correct is catalyst decrease the activation energy. Choice C is the correct answer. Next, question number 4. The rate constant for a reaction is this much at 50 degrees centigrade and 4.5 multiplied 10 to the 7 second inverse at 100 degrees centigrade. What is the value of activation energy? Okay, you see, you will do question number 4. K1 1.5 10 to the power 4 second inverse. Okay, at 50 degrees centigrade, so 50 plus 273, you will get 323 Kelvin. Okay, now K2 is how much? 4.5 multiplied 10 to the power 7 at 373 Kelvin. Okay, so log K2 by K1, log K2 by K1, you will get EA by 2.303 R delta T by T1 and T2. Okay, So log put all these values. Log K2 4.5 multiplied 10 to the 7 1.5 10 to the power 4 is equal to EA by 2.303 multiple R value 8.314 delta T difference. Your 50 100 minus 50 is 50, so 373 multiplied 323. Okay, so by solving this activation energy you will get activation energy 2.2 multiplied 10 to the 4. 2.2 multiplied 10 to the 4. So choice C is the correct answer. Next, in Arrhenius equation, K is equal to AE e the power minus E activation energy by RT. A may not be termed as a rate constant. When A may not be termed as a rate constant, at which condition? Okay, see, at a very low temperature, it may not be considered as rate constant. Okay, so choice D is the correct answer. Why not A? When 100% reactant will convert into the product, then what will happen? EA will be 0. Okay. Question number 5. When 100% converted, then EA is 0. Okay. So, and K, when the temperature becomes infinity, what will happen? Temperature infinity. When temperature becomes infinity, then what will happen? It will be infinity. So what will happen? K the power A K e the power minus E A by R multiplied 0. So this will equal to 0. So it will not happen. Okay. Then fraction of when the fraction of molecules crossing over the energy barrier becomes unity, what will happen here? When fraction of molecule crossing the energy barrier becomes unity, that is activation energy 0 is 0. That is 100% efficiency. 100% efficiency, EA will be 0. Again, K will be A. Okay, so at very low temperature, this is the correct. At very low temperature, what will happen? K is equal to very low temperature. You can neglect this. Okay, you can neglect this. So K is equal to A e the power minus EA by T. Next question. The rate constant of the product of 2B gas by the reactant A to 2B gas is this one. Okay, in A and B the ratio A is to 1, 1 is to 1 ratio AB. In the reaction mixture is attained after what? What is the ratio will be 1 is to 1 at what? A in the reaction mixture is attained after what time? The time is asked. Okay, so question number 6. You see, A to B. So what happened? T is equal to 0. Then here it is 1 and it is 0. When T is equal to T, what 1 minus x is converted? 2b, it is 2b given. It is 2b given, so 2x is converted. Okay, so given what is given condition? 1 minus x by 2x ratio 1 is to 1 is given. That means your 1 minus x is equal to 2x. Okay, 1 minus x to 2x. That means 3x is equal to 1. X is equal to 1 by 3. Okay, so your time See, K is equal to given. K is equal to 2.48 multiplied 10 to the power minus 4 second inverse. This is first order. Okay, this is first order. So K is equal to what will happen? K is equal to 2.303 by T log 1 by 1 minus x is equal to 2.303 by T log 1 by 1 minus x. X is 1 by 3. Okay, so you will get what? K is equal to 2.303 by T. Okay, log, you will get 3 by 2. Okay, so this is 2.303 by T log 3 minus log 2, log 3 minus log 2. Okay, so you put log 3 value 0.4770 minus log 2 0.3010. Okay, multiplied 2.303 by T. Okay, so this much is given. What is the value given? The value is given here 2.48. This much is equal to 2.48 multiplied 10 to the power minus 4. So by solving, you will get T is equal to 27. You will get 27.25. This much minute. So choice B is the correct answer. Okay. Next. Two substances A and B are present such that A0 is equal to 4B0. Okay, this is the condition given. A0 is equal to 4B0. And half-life of A is 5 minutes and B is 15 minutes. If they start decaying at the same time following first order kinetics, how much time will the concentration of both of them would be the same? Okay, so it is very important and interesting question number 7. Okay, so half-life period, see what is given. Half-life period, it is first order reaction. The first order reaction does not depend on initial concentration. Does not depend on initial concentration of reactant. Okay, first order reaction does not depend on initial concentration of reactant. Hence, it depends on the slow reaction. What is the slow reaction? It is given half-life A is 5 minutes and B is 15 minutes. So it is slow reaction. So generally, naturally, what will happen? The 15 minutes B on the same slow reaction, it will depend. So give the what time? The same time means it will take the 15 minutes. So choice A is the correct answer. Okay, students, have a good day.